Good morning, students. Welcome back. Today we are talking on CPU scheduling. First of all, we see what is CPU scheduling is. CPU scheduling refers to the basic concepts, scheduling criteria, scheduling algorithm, multi-process scheduling, real-time CPU scheduling, operating system examples, and algorithm evaluation. Okay, so there are some objectives of this topic or of this chapter. That is, first is introduce CPU scheduling, which is the basis of multi-programming operating system. Second is to describe various CPU scheduling algorithms. Third, to discuss the evaluation criteria for selecting a CPU scheduling algorithm for a particular system. And last is to examine the scheduling algorithm to serve operating system. Okay, so first of all we will see what is actually the concept of scheduling is. Okay, so we have to define what is CPU scheduling is. um, for defining CPU scheduling, we can say that CPU scheduling refers to the switching between processes that are being executed, or we can say the process of deciding which process will own the CPU to use while another process is suspended. Is it? So it means that which form the basis of or by that scheduling, CPU or operating system forms the basis of multi-programming system. This switching ensures that the CPU utilization is maximized or maximum, or we, we can say maximize, so that the CPU is more productive. For that purpose, we'll see the process life cycle. In process life cycle, I told you about some queues like job queue, ready queue, device queue, and for execution of such a queues, that figure shows actually how the jobs comes from one queue to the other queue. First of all, job is entered in a job queue, then it is entered in a ready queue. Whenever the job is entered in a ready queue, at that time it will convert it into the process. When the process is in a ready queue, it goes to the CPU for the execution. If that process requires some uh, input output or other resource, then that process is entered in a input output waiting queue. If process get its input output, then the process is again entered in a ready queue. This is the way actually the evaluation of the process. So we have to define what is ready queue, what is job queue, what is input output queue. See the definitions of it. Job queue is nothing but the queue keeps all the processes in the system, whereas ready queue is the queue keeps a set of all processes residing in main memory, ready and waiting to execute. A new process is always put in this queue. Then the next is device queue, or we can call it as input output waiting queue also. That process which are blocked due to unavailability of input output device constitutes this queue. Means if one process can acquire the keyboard, at that time no other process get the driver for that particular keyboard. So that process should be entered in a waiting queue for that particular device, like keyboard device. Is it? In this way, actually, practically, the process life cycle is executed. For that purpose, we have to decide which processes enter from ready queue to running queue. It means ready queue to CPU. And for deciding that, or for doing that, we operating system have to decide which scheduling criteria is used for the queue. That queue should be first scheduled, and then expected processes enter into the ready queue to the CPU. So we will discuss on that process. For scheduling or for CPU scheduling, the program is necessary known as a CPU scheduler. CPU scheduler is a or a, it is a software program which is responsible for ensuring no starvation due to high burst time process. Means scheduler can schedule the queue in this way that no any process creates a block for the execution of the other processes. Is it? What is a job done actually performed by the scheduler is scheduler selects from among the processes in a ready queue and allocate the CPU to one of them. That queue may be ordered in a various way. For ordering the queue, we will see the scheduling algorithms for it. Okay, for CPU scheduling, that decision may be placed when the first switch from running to waiting state, switch from running to ready state, switch from waiting to ready state, and then terminated. And for doing all these what we say processes, we require one system program. That program is known as a scheduler. There are different type of scheduler available. Basically, there are three type of schedulers: long term scheduler, short term scheduler, and medium term scheduler. So we'll see one by one. The first is long term scheduler. That long term scheduler is also called as a job scheduler. uh, that long term scheduler determines which programs are admitted to the system for processing. It selects the process from the queue and load them into the memory for the execution. It means long term schedulers are the schedulers which starts from job to successfully termination of the process. So these schedulers are called as a long term schedulers. Means collect a job from the job queue, enter that job into the new state to ready, ready to running, running to waiting, waiting to ready, ready to running, and then terminated. Okay, so these such type of schedulers are called as a long term scheduler. The primary objective of job scheduler is to provide a balance mix of jobs such as input output bond and process bonds, etc., etc. Okay, it also controls the degree of multiprogramming. If degree of multiprogramming is stable, then average rate of process creation must be equal to the average departure rate of the process living in the system. But it is very long and very complicated process, time consuming process. Is it? So long term schedulers are uh, not frequently available, or that schedulers never gives a better reply for the large scale multi-programming operating system. Means the multi-programming operating system can process at a time thousands or many more thousand processes. At that time, long schedulers never gives us a better result. So some limited operating system can prefer the long term scheduler for the scheduling. Means for enter a job from ready queue to running queue. The example of such type of operating systems are time sharing operating system is the example, and some uh, many rare examples of the long term scheduler. The second type of scheduler is a short term scheduler, which is a CPU scheduler. It is also called as a CPU scheduler. It means main objective of that particular scheduler is to increase the performance of the CPU or to increase the degree of the multiprogramming. For that purpose, it changes the ready state to running state of the process. Um, Means your scheduler starts from ready state to terminated state. So, like a long term scheduler, jobs that schedule short term scheduler does not think about the job queue. It starts from the ready queue. So, for that purpose, such type of schedulers are called as a short term schedulers. These collect a job from uh, running state ready state to enter that job into the collect a process from ready state and enter that process into the running state. One software program is necessary, or again one term is necessary, that is called as a dispatcher. Okay, which makes the decision of which process to execute next. So limited states have to perform in a short term scheduler. So short term schedulers are better than the long term scheduler, and many multi programming operating system prefers the short term scheduler. For example, Windows operating system, Linux operating system, and etc etc. Third type of scheduler is called as a medium term scheduler, or it is also called as a middle term scheduler also. Actually, this scheduler can prefer the process of swapping. What it means, let's see. It removes the process from the memory. In this scheduling, um, uh, running process may become suspended if it makes an input output request. A suspended processes cannot make any progress uh, towards the completion. In this condition, to move the process from memory and make space for other processes, the suspended processes is moved to the secondary storage. This process is called swapping, and the process is said to be swapped. The process is said to be swapped out or rolled out. Swapping may be necessary to improve the process mix. Such type of schedulers are called as a medium term scheduler, and figure clearly explain all these uh, processes. Itself, middle term scheduler required a extra swapper or extra data structure, swap in and for swap in and swap out. So middle term schedulers are also the schedulers which are not more preferred by the multi-programming operating system. Some limited multi-programming operating system use a middle term scheduler. Most of the operating system use a short term scheduler. And in this chapter, all the scheduling algorithms and all the next incoming terminologies or technologies for technology is not the proper word actually. The task performed by the operating system, we think or we use the schedulers, that short term schedulers means all the features we explain or we taught about based on the short term schedulers. Okay, so this is all about the scheduler. In next lecture, we will see what is dispatcher is and what are the different scheduling algorithms, what are the criteria of scheduling algorithm, and what are the different scheduling algorithms. Till then, goodbye and keep watching.